Hi everyone. We are going to continue our test management discussion with the next topic, namely incident management. And then I will provide the summary of this lesson. Okay, so for incident and defect management, so what is the incident? Incident reports. So we need the incident reports so that deficiencies, problems, and defects identified at different level can be corrected reliably and quickly. And then also we can keep track of the incident or defect that we identify during testing or during the operational of the software. So a well-functioning procedure for reporting and administering deficiencies and problem defect is called incident management. So it is also called a defect management or bug tracking. So it is referred to the same thing, defect management and bug tracking. So the definition that provided by IEEE, the defect management is defined as the process of recognizing, investigating, taking action to resolve defects so that we can keep track the defect that we found during testing. So the procedure begins after the end of a test run and then use the incident reports, including the incident classification, incident status, test log, etc. So in the certain project, we have the thing that we call it as a defect triage. That's decide on the incident classification, whether the bugs is severe, highly severe, or medium or low severity. Okay, so the test log. What is the test log? The test log is a chronological record that of relevant details about the execution of tests. So how it's happened, step by step, that we record during the test execution. That one will be logged in the report, the comment, including the comment that's you prepare during the test execution. Okay, the evaluation of the test log, mismatch expected and observed result. So this one is here when, for example, if I'm a test leader, I will check each tester entry in the test link, so I can see that what is expected and observe result. So that is a log about the testing. So the tester investigates whether failure exists. But we have to remember, as I already mentioned in the group project, that faulty test execution also may happen, where maybe possibly the environment is not set correctly, or maybe your test cases also may contain error. So it is not only the developer, the error caused by the source code or developer. So for the incident reports, the problem related to the test object, and incident report is created concerning the observation. When we see that, okay, there is something wrong because it is different from expected output and the actual output. So we create the reports that we call it as incident reports. So this is done for each mismatch of the test log. So avoid duplicates of incident reports. Sometimes it's also happen. Two incident reports, two bugs reported for the same error. It happens, and then during discussion we can eliminate one if we think that it is duplicated. And for the cost analysis is a responsibility of the developer. Is like debugging. So for the tester, tester only provide the bugs reports, and then it is a responsibility of developer to investigate further about the cause and what is the root cause of the error, and then try to correct the error. Okay, incident database. What is the incident database? Generally, a central incident database. It is also called as incident management tool. This tool or database can be as simple as Excel sheet, or the complicated software, or the software that is the complete software like Redmine, Jira, Bugzilla, so that we can register the bug inside there, and then it can be keep track, and then we keep updating the status until it is solved. So we can also produce the reports, produce the report. So, and incident management tool facilitate the recording and status tracking of defects and change. Because defect also have a life cycle. So when we put in our database or the management tool, we can we can detect and then can update the status. For example, open. So this is open. Assign. After open, we open when we create a new. Then we'll open one issue or one incident, one bug. And then when we assign to any developer, it is changed to the status to assign, for example, and then accepted by developer, or maybe the developer also can rejected. So we will discuss about that status, the possible status in each bug later. Okay, incident reports can be added from all people involved in development, but also from customers and user. So this is what kind of the thing that customers or users can do. It is like during a maintenance period when we put system go live under production. We have about 1 year maintenance period where user also can report. For example, if they try to save, we cannot save the file. So it can give a report to the call center, and the call center will add into the database. So incident reports can refer to the problem within tested program or also defects in the specification, user manual, and other documents. It is not only limited to the program that we test. And then all open problems are reported, but not every problem is a defect caused by a developer. Okay, so sometimes the defects is also caused by requirements engineer, caused by the customer, caused by the environment, etc. So we have to investigate. So every developer can comment and then can also reject. Reject. In what case? For example, the error, the bugs reported by tester, and then he said that, oh, this is not the bug. It's supposed to be like that, and something like that. So the developer also either can accept or reject. Most of the time, the developer will accept, but in certain cases, they also can reject the changes. For example, sometimes it is not an error, but lack of training by the customer, and the customer launch that report. The report is registered in the box. So because every entries in the database or in the bugs management system, every single bug will be monitored by the project manager or the test manager. So that's why it's we have to make sure whether the bug is closed or something that's made to close. For example, is rejected because of something. So after reject also can go to the close. So if a developer correct the test object, so and its report is also documents the incident database. Incident database is either Excel or not. Normally nowadays because of the complicated or the large number of defects sometimes that we handle, we use tools like Redmine. The example of tools is Redmine or Jira or Bugzilla. Many tools actually. This is among the popular one. So I have a experience of using Redmine. Okay, so at any given time, the test manager and project manager can get up-to-date and complete view. Can produce the report and the status at any given time. At any time, can log into the system, to the database, to the incident management tools, and then get reports so that we can produce the report. So this is the standards that we refer, mostly referred for test incident reports. So IEEE 829. Actually, you were introduced to IEEE 829 before when you build the test plan, test design specification, test case specification. This is a test case, and then this is a test plan. Okay, so you produce in the project 1, you produce in project 2. Okay, just example in the class project. and then test execution, you did it in the project tree, and then you provide the test summary report. But yes, last time you only report in your project tree. It's only the metrics that you use is the test case, whether test case is run or not run, how many percent run, how many not run, how many block, how many pass, how many fail. That is a test case metrics. So another report is you also can provide the bugs or defects metric. So how many bugs, new bugs open at certain dates, how many close, how many resolve, how many assign. So that is the statistic that you provide if you use defect metrics. But I didn't ask you to do the defect metrics. Why? Because you only do one round of testing. If we do a couple of rounds, then we need to keep track, try to see the trends of the graph. How many bugs solved? Let's say this week, we have 30 bugs, new bugs, 0 bugs solved. Next week, we're supposed to have a smaller than 30 new bugs, and then a greater number of bugs solved. So that is the so test incident report is for individual, not the test summary. The graph for the defect matrix is a test summary. For the test incident report is for individual that we can check. It depends actually. The format is depends to the tools, but this is a common for IEEE 829. The common element of test incident reports. First, of course, you need the report identifier. It is a very unique identifier. Bugs -3 CC also. So it is up to you to give the running number. The running number provided by the tools, but you can put the prefix there. The summary online, especially the impact on stakeholder. So you can say that this one is a showstopper. We will stop the operation of the system. That is very severe. Or this one is just a message, what we call annoying message that appear. So that's the summary, give an impact of a stakeholder, and then the description. You can see there input, expected output, actual result, anomalies, date, and sign, etc. So there's a large number of description, and followed by severity. So the severity is impacts the system of stakeholder interest. The severity is sometimes the company are asked to do the defect triage. Defect triage is when we have a session with the stakeholders to determine the defect. So it's not the decision of a tester to say that it's not decision of a developer, tester, and together with the stakeholders, the customer, to see to determine the severity of the incident. Incident priority is about the urgency, whether it is high or low or medium. So it is urgent. This one is urgent, this one is important. Severity is about how important. The priority is about how urgent. Need to do it immediately, or we can postpone until next release. There's also some bugs. That's after we decide, before we decide to go live, that we agree with the customer. That's okay, this one for the next release of the software, because the contract consists of many releases. The status is whether open, put on hold, rejected, the thing that we will discuss later. I already mentioned before about the status of each defect or bug that we store in the system. Later we will discuss about this in detail. Conclusion and recommendation of the detected defects, if you have a conclusion, and then history of change. What, when, who make a change. So when. So then it is easy to keep track. With the tools, most of the things here is automated, and then the template is prescribed. This is an example of that bugs report, but this is actual bugs report. Bug have an ID, as a summary, as also severity, priority, and then also version change tracking, time tracking, etc. So this is you cannot read. So we go to the next example that you can read. The bug report, for example, for web project bug reports. So summary in CTR, click-through ratio, total row calculation is wrong. So that is a summary about the result product. Which product is the example product? The product mean the component of the system that we deliver. The version, platform, URL, okay, is the severity measure. So measure means we have to pay serious attention. Priority is a P1, is the highest priority. So these two information give us the impression that this bug must be solved immediately, because it is will give a major severity assigned to the rest. I think so the reproduce step is also important. For example, when developer want to when a developer want to check again, to reproduce, so they can follow the step. This step is actually we can take from test case procedure or test procedure. So the steps or from the script. So normally people we combine the test link and Redmine so that the developer can go to test link to see the steps. And then test link also we can put API. I didn't set for this project, for your project in the class. But in the real project, we set API to link to certain Redmine system. So anything, let's say your test cases fail, and then you can register the bug straight away to Redmine. Maybe if I have a time, I can demo it to you how to do it. Okay, actual result, calculation of total and blah blah blah. So expected result. So this is must be there so that we can see the difference between actual result and expected result. Okay, so this is you need to master this. You need to be able to produce this. It is very important. Okay, this is what I mentioned earlier. That's a defect or bug have a life cycle. It is not bug life movie. It is a defect or bug life cycle. So we have a new, open, assign, test. Okay. So this is the thing that I mentioned about assign. It can be accepted and then test. Can be also deferred and then rejected. So new, we put this as a new bugs. And then the status is new. And then we decide to open this bug to proceed. Sometimes the screening also can be done at this stage. And then we open. When we open the bug, we need to assign to somebody to solve the bug or resolve the bug. So we assign to developer. The tester assigned to developer. So we have two person here. That must be recorded as the owner who create the bug, and then the developer who will solve the bug. And then the developer, when the developer will log into the Redmine system and then try to check whether they are assigned any bugs or not. They can decide whether to reject it. Why we reject? Because maybe it's not relevant or something like it's already duplicated. They found that it is duplicated. Can give a comment or deferred. Deferred means the developer has something else to do. It's very important, and then this one is least important. Priority is very low, and then can deferred. Or can accept, but it's not accept here. After accept, the developer will do some debugging. So debugging is here. Debugging. Try to locate error, find the source of error, something. And then the developer will test. So developer will put the status as resolved. After it's resolved, it's verified by the tester. And then close. So if it tests, if it is test and then retested the test happen at two levels here, the developer and also tester. So if testers feel that this cannot cannot solve, you reopen and then assign again, and then until it is closed. So this is a defect or bug life cycle. Must be tracked. This must be tracked, and then we can produce a report from time to time. Sometimes customer ask for daily report. It is not impossible. When the time of the peak time to go live, for example. Okay, so you can read this. I already explained. New, open, assign, test. So tests can fix, won't fix, can reproduce, why, and then deferred. This one rejected, duplicated, duplicate. So because of the duplicate, so it's also rejected. So this one is the if the bug is not genuine, then you can reject. With the twice of the bug mentioned, and then it is the letter verified. Yeah? It depends to the tools. This is just a common status. It depends to the tools. Some tools call it when the tester do the test, when developer do the testing. Some tools like Redmine call it as a resolve, but resolve is not yet solved. Right? Solve is when it's verified by a tester. Okay, so reopen and close I already explained as well. Okay, so this is the status essentially. Again, I would like to emphasize here that it depends to the tools. Yeah, but this is just a common status listed here. Defect classes. So this is the thing that's defects. What we call the effects of defects in practice. So sometimes we call it we call it defect triage session that's determine this. So severity, the potential impact to the system. So it is mission critical, application will not function. This one we call it as a showstopper. We can if this bugs happen and then the system fail to operate. Major, severe problem, but possible to work around. Still not stop the system from functioning, but this is a major. For example, giving what we call the incorrect result, saving incorrect result. The system is still can what we call can run. It's not showstopper, but major. It must be also solved. Minor does not impact the functionality or usability of the process, but it is according to requirements or design specification. Yes, but it is not according to. So it's something like just like maybe UX, user experience, or something like it's very subjective. Change the color of the system. So some I think you still remember about the exit criteria. Exit criteria. So we put this in our exit criteria. So for example, 100% of a mission critical and 95% of a major system severe, or maybe 100% of mission critical and major defects is solved. Then we can go live by exit. And so we cannot say 100% bug solved because there are also minor bugs that's registered in the incident database in our tools, incident tools. Okay, priority, as I already explained before, can be immediate, must be as soon as possible, delayed, and system is usable, but incident must be further or deferred to the next. They can left if necessary due to the time of the course. For example, next release. These are relevant standards. Many standards that you can use related to the incident management for the test manager. So we have also company standards. Each company have the standards. If you want to do the project in Malaysia for the government procurement, you need to follow the IVMV standards. There's guidelines there. The guidelines, not standards, but the guidelines. The standards come with the together in the guidelines. And then also best practice, non-standardized but technically proven procedures and processes. So we can document as the best practice, the step of, for example, in handling the bug. Also how to handle the bug, how to record the bug. So we put in the this best practice. So related to the standards, we have a software test standards like IEEE 829, and then the company standards is the in-house developed by the company. Best practices, quality management standards like ISO 9001, or maybe you have an internal QMS, internal quality management system. Industry standard, This one is also like a software test standard, but produced by industry. For example, railway application, Department of Defense US. So they provide for railway application. We have a ISO. This one like a software test standard, maybe ISO 12207. Okay. For the railway, as I mentioned before, there is also the standards like ISO. I couldn't remember the name, the number. So that is the for the certain for example the health application or hospital information system. There's also have a standards, these industrial standards. So that is the standards that govern the. I remember 15024. Okay, so this one is the number of the standards that we can use. So there's ISO 9000. So we have a 9000-3. This one for the software development. And then we have a number of, it's one, railway application, EN128. Okay, so I got the experience this when we developed for the MRT system. Okay. So this is 5128, and then there's a number of other standards. The industry is depends to the what type of industry, airborne systems. So you must comply to the standards. Software test standards, we have this one 8 to 9. We already discussed about this, and then there's a number of standards. 9126. This one is already replaced with square. But I cannot remember the number. Okay, but you already replaced with a new one. So you must keep yourself up to date with these standards if you work in the area of software development or software engineering or software testing or quality assurance. Okay, so these are also a number of technology standards that we have. Okay, with that, I think that's all for the last topic in our test management lecture.